Okay, so the next bit of differentiation is something called the quotient rule. So we've looked at what to do when we have a product. So when we have something like y equals u times v, we know how to differentiate that. I'm now going to look at what to do if we have something like u divided by v. Okay, I just wanted to point out u divided by v is the same thing as u times v to the minus 1. So I can still use the product rule. However, I think it'll be a lot easier, or in fact, it is a lot easier to use the quotient rule, so this thing here, because we won't have to deal with these negative powers and it'll be able to simplify a lot quicker. And also, we have the formula, so we can use it. Now, the formula, I'm going to write it in terms of using these because that's what we used to with the product rule. Although on your exam, you'll get S and G's. So it's the bottom stays as it is. We differentiate the top. Then we take away the top stays as it is. And we differentiate the bottom divided by the bottom squared. Yeah, so when I use that, I'm going to use this formula because it's just a bit quicker to write than this one here. Now, before we start using it, hopefully if you look at the top, if you ignore the bottom, look at the top, and if you change that sign to a plus, you should just get the product rule. So although you don't get given the product rule, you can kind of cheat and just cover that up, change it to a plus, and then turn it into the product rule. Okay, so first example, so differentiate y equals x squared minus 4x is 12 over x minus 3 squared using the quotient rule and simplify as far as possible. The fact that it says simplify, that means we need stuff in brackets ready to cancel out. So I'm going to leave the bottom x minus 3 squared as it is. Anyway, it's always good to leave the bottom factorized. So first thing we have to do is we have to identify what u and v are. So u is the top, so x squared minus 4x plus 12. V is the bottom, so x minus 3 squared. Differentiate both of them. So 2x minus 4. And this differentiates to give us, remember, times by the power, take away 1 from the power, then I'll have to times by the derivative of the bracket because that would be my u, but x minus 3 differentiates to 1, so I times it by 1, it just stays as it is. Okay, then I can use the formula, and it's always a good practice to write down the formula. So v u dash take away u v dash over v squared. Then we sub everything into the formula. So actually, I'm going to do the working out here. So dy by dx is v, so x minus 3 squared times this. So we still get the same pattern, times 2x minus 4, take away these two. So x squared minus 4x plus 12 times 2x minus 3 all over the bottom, so v squared. Okay, I'm just going to simplify that slightly. So the first bit, can't really simplify that, so I'm going to leave it as this. The second term on the top, I'm just going to put the 2 to the front. And then the bottom, I can write that as x minus 3 to the power 4. In fact, this one here, I can put a 2 to the front as well, because I can factorize that out by 2. So I get x minus 2 left. This bracket here can't be factorized. It looks like it can, but it can't. Okay, so I've simplified as much as I can. So I'm now going to factorize to see if anything cancels. So on the top, I can definitely factorize it for 2. Now here, look, both these have got an x minus 3. So I can take out x minus 3. Let's see what's left. Well, from this first term, I've still got an x minus 3. I've got an x minus 2. From this term, the 2's went out. The x minus 3's went out. So I've just got that quadratic left, x squared minus 4x plus 12. And on the bottom, I've got x minus 3 to the power 4. Yeah, because remember, we just times the powers up here. Now this bit, so I can simplify here, look, I've got x minus 3 and 4 of them there, so I can cancel out one of them. So I've got 2 on the top, and I'll have 3 of these on the bottom. So I have an x minus 3, x minus 2, take away x squared minus 4x plus 12. Okay, now I'm just going to expand and simplify. So this bracket here gives me x squared minus 5x plus 6. Take away x squared minus 4x plus 12 all over x minus 3 cubed. So that gives me, if I simplify that, x is cancelled out. Minus 5x minus 4x gives me minus x. 6 minus 12 gives me minus 6 over x minus 3 cubed. And just a nice way of writing that, minus 2, just factorize it minus, so x plus 6 over x minus 3 cubed. Okay, now some of these answers could look a bit weird, so I'll show you a nice trick to check. So if you go in your graph mode, and if you type in your answer, so minus 2x plus 6 over x minus 3 cubed, and then also type in what we're differentiating. So here, but to type in, I'm going to go into look options, calc, and there's a button for d by dx. So I'm going to type in the first bracket, just what we're differentiating, so x squared minus 4x plus 12 over x minus 3 squared. And here, this little bit here, x equals, so normally you would type in what value you're differentiating at, but I'm just going to put an x there. And hopefully these two graphs should be the same thing. Yeah, since they're the same thing, the blue equals the red, then I've differentiated correctly. Okay, example 19. Luckily, we don't need much space for this. So you're given that in the formula booklet, that tan differentiates to x squared. Now we're going to prove it. Well, to prove it, let's start by writing y equals tan x and think what tan x is. Well, it's sine x over cos x. So it's a quotient, so we can use the quotient rule. So u equals the top, v equals the bottom, then we differentiate the top. Sine differentiates to cos, and cos differentiates to minus sine. Use the formula, so it's v first, then u. So the formula, I'll write out again, but I'm going to be lazy because it's up there. So dy by dx equals v first, so cos x times cos x. Take away sine x times minus sine x divided by v squared, so cos x squared. So simplified. So on the top we have cos squared x minus makes a plus sine squared x all over cos squared x. Well, cos squared plus sine squared is 1. So that's 1 over cos squared x. Look, 1 over cos is sec. So 1 over cos squared is sec squared x. Yeah, and the final one. So we're going to differentiate x over x plus root x plus 1. We're going to give our answer in this form. Now, this little symbol here just means a positive whole number, means a natural number. So like 1, 2, 3, 4, 5, 6, etc. So we want all our constants here to be positive whole numbers. So this means we're going to have to play around when we simplify it. So the first thing we're going to do is just rewrite it. So it's ready to differentiate. So square root is power half. Write down what u is. Write down what v is. Differentiate u and v. So remember, times by the power, take away 1 from the power, and then times by the derivative of the bracket. But again, that's just 1. And then it's v first, then u. So the formula, again, I'm just going to write it here, is v u dash, take away u, v dash, v squared. So dy by dx is Well, it's x plus 1 to the half times 1. Take away x times a half, x plus 1 to the minus a half, all over x plus 1 to the half squared. Again, before I start factorising and simplifying, I'm just going to simplify each individual term. So x plus 1 to the half minus, well, we have to put numbers front to front, so half x, x plus 1 to the minus a half, all over times powers, that's going to be 1, x plus 1. In fact, I'm going to leave it to power 1 so we can see what's coming. Okay, now we're going to do some factorising. Now, when we factorise with fractions, it's good to kind of write fractions on both of them with this same denominator. So I want 2 in the bottom there, so that means I have to have 2 in the top. So to factorise the top, well, I can take a half out. And when you factorise terms, so that's something to the power of a half, something to the power of minus a half, then we always factorise out the small power. So if I had x squared and x cubed, you take the x squared out, wouldn't you? So I'm going to take this out. So what do I times this by to get that? Well, I need 2. And I've got power of a half. I'm going to times it by something to get power positive a half. So that means I need to add 1. So times by x plus 1 power of 1. Yeah, that was quite tricky, so you might want to pause it, rewind it, and hear that again. The second bit, I took out the half, I took out this term, so I've just got the x left there. And on the bottom, I've got my x plus 1, about 1. Okay, now this thing here, I can simplify. X plus 1 to minus a half, 2x plus 2 minus x, all over x plus 1. And again, I'm going to keep the power 1. Because it's going to eventually end up changing, look, and the question's going to change. Okay, so that gives me half x plus 1 power minus a half, 2x minus x is x, so x plus 2, all over x plus 1 to the 1. Okay, so I've simplified as much as I can. So I'm going to look at how the question wants it. So once it's written back in terms of roots and all that. So if we look back at what we've got, well, I've got a fraction for starters, and I've got a negative power. So I want to deal with these two things. So if I'm timesing a fraction by something, I can put that something just at the front, so not as part of the fraction. So I can write it as half times x plus 1 to the minus a half times x plus 2 over x plus 1 to the 1. Yeah, that's the same thing. So like you just times the tops together, times the bottoms together. Okay, and I'm going to rewrite the second term. That's 1 over x plus 1 to the half. That's what a minus power is. And the final step is just to simplify it. So times the tops together. So x plus 2 on the top. On the bottom, I put a 2, x plus 1. Add the powers. So 1 over half is 3 over 2. And then finally, to rewrite it how it looks like this, square root back in it. Remember, flower power, so the top is the power, bottom is the root. It's x plus 2 over 2 square root x plus 1 cubed, that's the power. And again, you can type on your calculator and type d over dx of that in your calculator and see if they give you the same graph. But I'll leave that for you to do.